Welcome to another episode of Software Explorations, Concept and Overviews, hosted by your truly tech coach, Ralph, where we're engineer twin. In today's episode, we're going to be going over Kubernetes. It is a DevOps tool. We're going to dive deep into that. In the past, I've had some interest in learning more about Kubernetes. However, the computer that I was using was not powerful enough to be able to handle all the things that went along with it. But we are in a different shape now. We're in a different place. So we are going to be diving into it very, very soon. But I wanted to start off with getting a much better overview. This is my real first time digging into Kubernetes. I'm very familiar with Docker and things of that nature, but not with Kubernetes. Not with Kubernetes. So we are going to be getting into it together. I'm going to be learning with you. It's probably going to be a 2, maybe even 3-part series because there is a lot of information to cover. But before we go on any further, do me a big, big favor. If you haven't done so already, go ahead and subscribe to the channel, like the video, share it with a friend, hit the notification bell so you know every time we go live and drop new content. As well, go over to techcoachralph.dev, sign up for exclusive content where I share the sprint reviews that we do in our Tech Barbarians coaching group. I share that with you guys for free. I share the whole Scrum Night as well, where we do our sprint review, our sprint retrospective, and our sprint planning for our next sprint. Very good information if you're looking to be into tech to see how things work on a tech team, and as well as exclusive content that you can definitely tune in for. And if you need one-on-one coaching, or if you want to join the Tech Barbarians, you can sign up for that as well. That is techcoachralph.dev. But let's jump into this presentation. All right, so our topic for today is Kubernetes, orchestrating containers for scalable applications. So let's get into it. Our agenda for today, we're going to be talking about what is Kubernetes. We're going to talk about why people use Kubernetes, the core concepts of it, the architecture, how it works. We're going to talk about Kubernetes in action, some key objects and resources, some challenges that are faced, and then we're going to wrap it up. And then we'll go into what we're going to be looking at for next week in regards to Kubernetes. So let's jump into it right away. So what exactly is Kubernetes, right? So Kubernetes is an open source platform designed to automate the deployment, scaling, and management of containerized applications. If you remember, containerized applications are, things like Docker, where you can make an image and you can create a container from that image. So Kubernetes is going to be automating the deployment, the scaling, and the management of those containerized applications. It provides a framework for running distributed systems resiliently. Kubernetes organizes containers into clusters, which consist of nodes, which are machines that run your applications. It automatically handles the distribution and scheduling of containers across these nodes to ensure optimal resource utilization and high availability. So pretty much scaling your applications to make sure that it has the right amount of CPU, the right amount of memory, the right amount of machines that are running. Kubernetes monitors the health of the applications and automatically restarts, replicates, or reschedules containers if they fail. It also offers horizontal scaling, allowing applications to scale up or down based on demand. So based on the need of the application, let's say it's getting hit very heavy, and it needs more resources. It should be able to handle that. And then once the resources that it needs goes down, it should scale it back down. So let's get into some history of Kubernetes, right? So it was originally developed by Google in 2014. So it's about 10 years old now, right? As an internal project to manage their massive containerized workloads. It evolved from an earlier internal Google system called Borg, which was used to manage containerized applications across thousands of servers. In July 2014, Google released Kubernetes as an open source project under the Cloud Native Computing Foundation, CNCF. This move aimed to provide a standardized platform for container orchestration across different cloud environments and make it accessible to a broader developer community. Kubernetes quickly gained traction in the tech community due to its flexibility, scalability, and extensive ecosystem of tools and integrations. So, and that's the cool thing, right? So we have Docker that we can create these containers and we can like set them up manually and stuff like that, but that is so much effort. It seems like Kubernetes is what swoops in there and it's all right. We have this application that's containerized, but we need a better way to maintain it. And this is like the heart of DevOps itself, because with development and with operations, how can we get things to run more efficiently? And Kubernetes just adds to our tool belt. It became the de facto standard for container orchestration with contributions from major companies like Red Hat, IBM, Microsoft, and AWS. Today, it is one of the most widely adopted platforms for managing cloud native applications. And we're definitely going to dive into Kubernetes on our live streams so we can figure out how to use it. We want to get very well versed in it, especially if you are looking to get into DevOps and things of that nature. So, what are some of the key features of Kubernetes, right? So, we're going to read through each of like through this list, and then we're going to talk about each one of them and one by one, right? So, key features: automated scheduling and load balancing. It's self-healing, horizontal scaling, service discovery and load balancing, storage orchestration, configuration management and secret handling, rolling updates and rollbacks, extensibility and modular architecture, multi-cloud and hybrid cloud support. All right, all cool things. Let's jump into it. So, automated scheduling and load balancing. Kubernetes automatically schedules and balances containers across a cluster of nodes based on resource requirements, ensuring optimal utilization and distribution of workload. The self-healing part. Kubernetes continuously monitors the health of applications and automatically restarts, reschedules, or replaces failed containers to maintain the desired state and ensure high availability. So the horizontal scaling, right? Kubernetes supports horizontal scaling, allowing you to easily increase or decrease the number of running containers based on demand, either manually or automatically using metrics. So pretty much you set requirements, you set parameters in place to start. If the application gets to, let's say, this much memory usage or this much CPU usage, right? We want to add like maybe two more applications or to be able to handle it better, because there's, depending on the industry that you're in, these applications can get heavily like a lot of requests, and in order to be able to handle it, it needs to know at what threshold to start increasing its resources, right? Service discovery and load balancing. Kubernetes provides built-in mechanisms for service delivery and load balancing, enabling containers to find and communicate with each other without manual configuration. So you set it up in a way that they can easily talk to each other, and it's like there's not a bunch of manual intervention that's needed. Storage orchestration. Kubernetes allows you to automatically mount storage systems of your choice, whether from local storage, public cloud providers, or network attached storage. Configuration management and secret handling. Kubernetes manages application configuration and secrets securely, ensuring sensitive data like passwords and API keys are protected and not stored in container images. That's super important because you don't want, like, it's just a security risk, right? Like we talk about cybersecurity on this channel. You want to have all your passwords and your configurations protected, because if it gets into the wrong hand, it will be absolutely devastating. So, rolling updates and rollbacks. Kubernetes supports rolling updates, allowing applications to be updated without downtime. If something goes wrong, it can automatically roll back to the previous stable version. So that's really cool, because if on a deployment something is bad, for who knows what reason, it will roll back to when it was working previously, which is super helpful. It helps prevent downtime. Extensibility and modular architecture. Kubernetes is highly extendable with a modular architecture that allows integration with a wide range of plugins, tools, and custom resources to meet specific use cases. So, as we get into it, we're going to see, like, in the different examples that we're going to be implementing it, we're going to see what we have available and what we can use. And the multi-cloud and hybrid cloud support. Kubernetes is designed to run on multiple cloud providers and on premises, offering flexibility to deploy and manage workloads in a hybrid or multi-cloud environment. So super useful. It's very diverse. So what are some of the benefits of Kubernetes, right? So we have improved scalability, high availability and reliability. It's portability and flexibility, faster dev and deployment cycle. So it's pretty much a lot more efficient. Cost optimization, you save some money. Enhanced security and compliance. Definitely, like security and compliance is one of the key things, especially if you're working in a regulated industry. So it's not like you just learn a little bit of this, a little bit of that, and then you're good to go. No, you need to be able to display that you have your security minded as well, security and quality minded, right? And that's one of the things that a lot of people lack when they're getting into the tech industry. It's like, oh, I took this boot camp, I know how to do this, but you're missing so much. Like, it's like, honestly, to be honest with you, like going to the boot camps and stuff like that, that's like going to pre-K. You know, it's just the basic, and you're not even in kindergarten yet. All right, so let's keep going. So ecosystem integration and then standardized community support. Very important to have that standardized community support, because having that, like, where you can get your questions answered, where you can be able to search if something's going wrong, how do you fix it? Very important, especially with open source tools, because there's some open source tools that have absolutely no support whatsoever. So although they do a good job, they end up kind of useless because like if something goes wrong, who do you talk to? So let's talk about the core concepts, right? So there's pods, the smallest deployable unit in Kubernetes. A pod represents one or more containers that share the same network and storage resources. Pods are basic building blocks for running applications in Kubernetes. Nodes, the physical or virtual machines that make up a Kubernetes cluster. Each node runs pods and contains the necessary components like the kubelet and kubeproxy to manage networking and container runtime. And when I was trying to learn Kubernetes, that's pretty much as far as I got, because when I tried to like start up the kubelet and the cluster, my computer said nope, not happening. But now we will definitely be able to do it. So there's clusters. A Kubernetes cluster consists of multiple worker nodes, and a control plane that work together to orchestrate containerized applications. The cluster provides a single unit of management for deploying, scaling, and managing workloads. And here's the cool thing, right? With the work that we do in the Tech Barbarians, like we use Docker heavily to be able to start an application. So now, once we're learning Kubernetes, we're going to be able to set up Kubernetes to run the application that we've built. And it's just like everything works together so that we can like we're while we're learning this stuff, we're actually applying it in a practical way to real applications. And that's the goal. Like to me, that's one of the best ways to learn what you're learning. How can you apply it to a real life situation? So we have this application where it's running in the real life, in the real world. We just extracted it to turn it into a microservice, which goes hand in hand with Kubernetes, and Docker. So now like it's Dockerized. We're working on getting the front end in a next sprint or so. We're going to get the front end to be its own microservice, and now we should be able to start that up on Kubernetes. So that's going to be one of my first goals once we start working with Kubernetes, to be able to deploy our application on our local Kubernetes to see how that works, right? So just a little sidetrack to let you know like the kind of things that we work on with the Tech Barbarians, right? So services. Kubernetes services provide a stable IP address and DNS name to enable communication between pods and external clients. They abstract and expose a set of pods as a network service, ensuring reliable access regardless of changes in pod IP address. Right. So it's all about it's about the networking for the services. Very cool stuff. So let's talk about the architecture real quick. We're definitely going to dive a lot deeper into this, but I just wanted to give this graphic of the architecture. But then next week we're going to dive into like what each of these things do, what they mean. So yeah, like you can access Kubernetes either through the UI, the API, or the command line interface, right? So you have like the UI is like a GUI where it's either maybe a web thing or a software on the computer. Then you have the API where you can send requests back and forth to it to have it to do things. And then you have the command line as well, where you can interact with Kubernetes through the command line. So interacting with it, you have the different tools that are going to be using where it says master. It's like I guess that would be like the control panel, and then you have different nodes or pods. Like we'll break it down a lot better, but you have the master and then you have the worker, right? So the workers can consist of the kubelet, and then they'll have different nodes. Those look like Docker. Logos. So the node would be associated with a Docker instance, I guess. So we'll figure that out as we dig deeper into the architecture, and next week as we break it down. Because like I said, I'm learning this with you. So if anyone has better understanding who's watching this video, feel free to break it down and leave me a comment. But we're definitely going to get a lot more deeper into this next week. So how does it work? So with the cluster, a Kubernetes cluster consists of multiple nodes, node workers, and a control panel that work together to orchestrate containerized applications. The cluster provides a single unit of management for deploying, scaling, and managing workloads. Right. So if we go back real quick, so this looks like it would be the cluster, right? Let me see. Cluster consists of multiple nodes, worker nodes, and a control pane. Or maybe this one thing over here. Maybe this one thing over here is the cluster. I don't know. We're gonna figure it out. We're gonna dive a lot deeper into it to get a better understanding. So services. Kubernetes services provide a stable IP address and DNS name to enable communication between pods and external clients. They abstract and expose a set of pods as a network service, ensuring reliable access regardless of the change in pod IP address. So, what are the benefits of Kubernetes? So, the we have the cluster structure and the setup, right? We have the pretty much orchestrating, for lack of a better term, deployment and desired state, the scheduler and the controller manager, the node operation and pod management, the networking and services discovery, scaling and self healing, rolling updates and rollbacks, which we covered some of those things as the benefits, and probably next week we'll dive in a little bit deeper into them to get a better understanding. But all those things are why people really um, prefer to use Kubernetes when they're working with containers, especially in a large environment. So some examples of Kubernetes in action would be microservices deployment, which is that's something that, like I mentioned earlier, we're going to try because the app that we built with the Tech Barbarians, we were extracting that to a microservice, and then like the mobile apps that we're building as well, if it has an API component to it, that's also going to be a microservice for the API, and then different mobile device mobile applications can plug into it, right? So microservice deployment, continuous integration and continuous deployment pipelines, CI/CD pipelines, big data and machine learning workloads, especially like if it needs like heavy computing power to be able to manage a bunch of containers, hybrid and multi-cloud deployment, edge computing, high traffic web applications development and testing environment. So what we'll do, we're going to get into a few of these examples, but then next week and next week's presentation, we'll get the other examples as well to get a full better understanding of like different ways that Kubernetes can be used. So let's talk about the microservice deployment, right? An example, a company like Netflix uses Kubernetes to manage its microservices architecture. How it works. Each microservice, for example, the user authentication, recommendation engine, and billing, is packaged into its own container and deployed as a pod in the Kubernetes cluster. Kubernetes automatically handles load balancing, service discovery, and scaling of these microservices to ensure high availability and efficient resource use. If a microservice instance fails, Kubernetes automatically restarts or replaces it to maintain uninterrupted service, right? So think about it. With a company as large as Netflix, who's providing millions, maybe even billions of people across the world access to videos and things like that, it's you really can't really afford that much downtime, and using Kubernetes to manage that is going to make it a lot more efficient, because there's no way possible that Netflix would be able to do everything that it's doing manually. So they definitely are using some type of automation all across the industry, all across their company. CI/CD pipelines, so continuous integration, continuous deployment pipelines. So the example, a software development team uses Kubernetes to automate their CI/CD pipelines. How it works: Kubernetes integrates with CI/CD tools like Jenkins, which we've been going over on Thursday nights, GitLab CI, or Argo CD to automatically build, test, and deploy new application versions. When developers commit code changes, the CI/CD tool triggers a pipeline that builds a new container image, pushes it to a container registry, and deploys the updated version to a Kubernetes cluster. Kubernetes performs a rolling update, replacing old pods with new ones without downtime, ensuring smooth deployment of new features or bug fixes. So it sounds like it sounds very helpful, very, very cool. What about big data and machine learning, right? So a data analytics company like Spotify uses Kubernetes to run big data and machine learning workloads. How it works: Kubernetes manages distributed data processing frameworks like Apache Spark or machine learning libraries like TensorFlow. It dynamically allocates resources based on workload demands, such as scaling up pods for parallel data processing tasks or model training jobs. Kubernetes also simplifies managing dependencies, versioning, and monitoring these workloads, improving efficiency and reduce operational overhead. So, a question I have for my friend Mitch, right? One of my great friends, Mitch, because he works in data as data analyst, as data engineer, data scientist. He's like all those things. He's like super data. Right? I'm just gonna call him super data, right? So I'm wondering, like, do you like in the company that you work for, do you like does the company make use of these type of tools in order for you to be able to process your data and stuff like that, like Kubernetes and Docker, to be able to spin up containers running in this distributed environment, and that like it helps you get information back a lot faster? I'm just curious. Let me know, Mitch, because that would be really cool, especially like knowing all the capabilities, and if they're not using it, maybe it is something that you can use that'll help you and whoever. So edge computing. I have absolutely no idea what edge computing is. We're going to do some more research into edge computing. But the example, a retail company uses Kubernetes to manage applications at the edge for real-time data processing. How it works. The company deploys Kubernetes clusters on edge devices, for example, point of sale systems. Oh, okay, so that's what edge devices and in-store servers to run applications that process data locally, like inventory management or customer behavior analysis. Kubernetes manages the deployment, scaling, and updates of these applications across thousands of edge locations, enabling low latency processing and reducing dependence on centralized cloud infrastructure. Very cool stuff. I didn't know that's what edge devices were, but it's a point of sale devices and in-store servers. So you learn something new every single day. All right, let's keep going. So the core objects and resources of Kubernetes. I'm just gonna read through each of these, but then we're gonna break each of them down next week. We're gonna get into like these core objects, and then we're gonna get into advanced objects and resources for Kubernetes. This is gonna be next week, because this is very, very important, especially if you're interested in DevOps, right? Being able to understand Kubernetes and maybe even being even able to deploy it, all that good stuff, very, very important to your development. Because, like I said, I had a consultation this morning. I'm like, you can learn how to pass a test by reading a book, but using it, that is the key. So right now we're just doing the concept, but once we get our hands dirty, we're going to run into so much trouble, and it's going to be very, very helpful to understand what these things are, right? So core objects, pods, nodes, namespaces, deployment, replica sets, services, config maps, secrets, volumes, and ingress, right? Keep those terms in mind. We're going to break each one of them down next week. And if I tried to do all this in this one video, this video would be going for hours. And I'm like, we don't have that type of time for today. And I don't want to overwhelm you with all this information, which for me, I'm already a little bit overwhelmed myself. But we're going to break this down in a part 2 to go through each one of them to get a better understanding, because we need to know this, because we're going to use it. We're going to use it. We want to know what we're talking about. All right. So let's keep going. So, what are some challenges that people face in when getting set up for Kubernetes, right? So, there's a complexity to setting it up and managing it, but that's why we're here to learn. We're going to learn this together, and we're going to win, all right? We always win. We don't miss, all right? We don't miss. There are no days off, all right? So, steep learning curve. So there can definitely be a steep learning curve whenever you're getting to these type of tools. Resource overhead, security complexity, networking and storage challenges, monitoring and observability, continuous integration and continuous deployment, and the complexity of that, and then difficulty and debugging and troubleshooting. So at least we know what we have to look toward. However, don't threaten me with a good time. I am with it. I am all for it. Let's get it. Let's run it up. All right. So that wraps it up, right? So in conclusion, what we spoke about today is we went over what Kubernetes is, why people use Kubernetes, why people in tech use Kubernetes, the core concepts, the architectural overview, which we're going to break down definitely next week in more detail, how Kubernetes works. We looked at some examples of Kubernetes in action, the key objects and resources. So about the key objects, like I said, we just went over the list, but we have to break it down a lot more. We spoke about some challenges that people face when getting started with Kubernetes. And some challenges that people and teams face and companies, organizations face when getting started with Kubernetes. So let me know what you guys think, right? Let me know what you guys think. If you have any questions, drop it in the comments. If you have any feedback, drop it in the comments. Whatever the case may be, I would love to hear from you, because this is very new for me. I'm very, very excited because I just love this type of DevOps stuff. I love this type of data stuff. I love QA stuff. I love all things tech. So, and the fact that we actually have real applications to put it to use, it's just like Christmas comes every single day for me. All right. So let's get into what we're going to be talking about next week. So next week, we're going to go in depth into the core objects and resources and the advanced objects and resources as well. We're going to break down the challenges one by one. We're going to explore the best practices, and then we're going to talk about the future of Kubernetes. So stay tuned. That's what we have coming up next week. We're going to break all those 4 points down into greater detail, because this is very, very important to our development in DevOps and into tech, into QA, into development. This stuff is critical that we get a good understanding of it, that we grasp it, and I just can't wait till we actually start implementing it on the live stream. All right. So like I said earlier, let me know your thoughts. Did you find this helpful? Did you find this informative? Did you have any questions? Do you have any feedback? Maybe we can do something better. Let me know. But whatever the case may be, I am here for you. We'll get it done. All right. Let's go back to full screen. All right. So let me know your thoughts. Like I said, let me know your thoughts. I hope you found this helpful and informative. If there's anything else you want us to cover, if there's anything in particular you want me to cover, by all means, I am here for you. Let's do it together. Let's do it together. We don't miss. All right. With that being said, we're gonna wrap it up. But before I go, I just wanted to thank you guys for watching again. And do me a big favor if you haven't already. Like the video, share the video, subscribe to the channel, hit the notification bell so you know every time we go live and drop new content. And as well, go over to techcoachdrive.dev, sign up over there. You get access to my sprint reviews that I do with the Tech Barbarians every 2 weeks. I'm going to be dropping those sprint reviews because it is important, not only for my Tech Barbarians, but it's important for you to see how things work, how software is built. You know how they say how the sausage is made, right? How things are working under the hood, so that you see how we work as a team, and you can also see the full Scrum Night as well, where we do the sprint review, we do the sprint retrospective, and we also do our sprint planning for the next sprint. And if you want to be part of the team, if you want to work with me one-on-one, if you need coaching, if you need to build experience, if you need to get resume assistance, if you need to do mock interviews, all that good stuff, go to techcoachdrive.dev, sign up there. You can sign up, like there's different tiers. If you want to work one-on-one, sign up for that tier, and then we will run it up together. Like I said, we don't miss. There are no days off. All right. And one more time. There are no days off. You are responsible for your own success, right? I'm just in your corner trying to help you out, but you are responsible for your own success. So you either get out there and get it, or you get left behind, because guess what? We will leave you behind. All right. I'm gonna leave you with that. All right. But that being said, thank you guys so much for tuning in. This is Tech Coach Ralph with another episode of Software Explorations. We are out.